Hi, today we're going to talk about from learning gaps to growth in years 7 to 10 maths. I'm Kathy. I'm the head of maths at Edrolo. I was an international school teacher for 12 years. I taught at the International School of Beijing and the Shanghai American School, and I have a math specialist at International Schools credential. I also have a bachelor's of science in economics from Duke University, and I've been the head of math working at Edrolo for the last 6 years. Today, we're going to talk a little bit about a diagnostic assessment called MESHA and how we've designed it and used it to help us find the learning gaps in our classrooms and how we have turned that into results and growth. So let's get into it. Where this came from, probably a few months ago, I was at a conference and saw Diane Seaman, and she made this comment about how in classrooms today, especially in math classrooms, we can see up to 7 years of variability in the classroom. So as teachers, we know that we have so much to handle and so much to do in the classroom that understanding where our students are at is really important. And so this is sort of the idea behind MESHA. The problem that MESHA solves is that there is a lack of timely, actionable feedback for teachers currently. So what's out there, what teachers really like to use is like the wrap item analysis that you get back post HSC, which can tell you on an item by item level of where your students are at compared to the whole cohort. And this is great information. However, it's not really actionable because that cohort has already left school. So it's good for you to know in your school and designing the curriculum, but you can't really action it with your class. So the solution that we created is called MESHA, and MESHA stands for Math, English, Science, and Humanities Assessment. And what it is it's an assessment that is set 2 times a year in years 7 to 10. It sits within your normal class period. So it sits within a 40-minute assessment window. You do not need to get all your students together and put them into an assessment hall. You don't have to change any of your timetable. It really could just be the lesson of that day. And it's delivered online through the Edrolo platform. And it's delivered online so that you can get timely, actionable insights. So you'll be able to see how your students performed immediately after the test is completed. And then 10 days after the assessment window closes, you'll be able to get a comparative, comprehensive report that you can action immediately. So we built this assessment in partnership with Dr. Greg Ashman and also with 7 of the top New South Wales schools. So you can see here, we worked with Newcastle Grammar, Cranbrook, Knox Grammar, the Illawarra Grammar School, Trinity Grammar, St. Catherine's, and Ravenswood School for Girls. So what is the assessment design? So the design is that there are 32 multiple choice questions. There's 2 sections with 16 questions each. The first section is a no calculator section, and the second section, you can use your calculator. So this was designed intentionally as well, so that even though we know as students move on into the senior math and they use more of the calculator, understanding the foundational non-calculator skills will help them when they get to that point. The question design follows. They're all tied to a specific curriculum dot point, and they're also tied to a specific math misconception. You can see on the right-hand side that they follow most of the topics in the curriculum, all of the topics in the curriculum, so measurement, algebra, numbers, statistics, probability, and space. There's a heavier emphasis on number and algebra as the foundation of math. And then there are also measurement questions as they really lean into those skills as well. There's a variety of procedural, worded, and abstract questions. And every year, there's a separate purpose-built assessment that's written for every year level. So it will follow that natural progression for math. And then every year, there's a new assessment that is written. We'll get into it a little bit more, and that's one of the features of this assessment as well, is that as teachers, you will get a copy of the questions, and often in NAPLAN, you can't see the questions. So you'll get a copy of the questions that you can go back and dig into with your class. So I talked a little bit about the reporting. You'll get the reports back 10 days after the assessment window closes, and you'll be able to see how your school performed against other like schools. So it's anonymized. People will not be able to see your school name or your students' names, but you'll be able to see how you compare to other schools that are similar to your school. So it could be your SES, or it could be also your ranking, or it could be even demographically where you're situated. It will highlight class and student level misconceptions. So what does that really look like? So let's start digging into it. You'll get a report back that's on 3 levels. It'll be on the student level, the class level, and then you'll have a more granular misconception report for your class. So at the student level, you'll get a report that's in an Excel CSV file that will list all of the students and how they perform. This is pretty much your normal Goodman chart. You can see how they performed across all of the questions. At the top, you'll be able to see how your school performed compared to the MESHA cohort. So you'll be able to see how is your school tracking overall to other like schools. What are some of the areas of your strongest performance? And what are some of the areas of learning gaps? And what is really helpful when you're looking at all of the students is if you are streaming your classes, and in New South Wales, especially as you're moving into stage 5 and getting ready to go into the different pathways of advanced and standard, you can see if you've streamed those students correctly. So a case study using this from our Victoria pilot is that there was a school that was looking across at all of the questions. And notice there's one question where they did perform really low. And they were able to then look at the entire MESHA cohort and saw that the cohort in general also scored really low. So as I mentioned before, you'll get a copy of the test. So they went back and looked at the question, and they found that the question was actually a year 7 dot point that was on finding the net of a 3D shape. And this was something that was in the year 7 curriculum, but it wasn't taught again in year 8. But as we know, as understanding the net will help when you're starting to look at surface area and looking at surface area of 3D shapes. And that's something that they needed in year 9 or in stage 5. And so this school was able to then see, wow, we didn't teach this not because of anything else, but it wasn't on the curriculum, but that they needed to review it and have that spaced retrieval. So then they were able to action it at the end of the year. They had sat the pilot in term 3, so they were able to action it in term 4. So when the students went to year 9, they did have this knowledge again. The next example of the report is a class report. So you'll see here, you'll be able to see all of the classes in your school, and they'll be side by side. And you'll be able to then also see how your school performance was, so how the classes compared to the school. And then you'll also be able to see the entire MESHA cohort. So how did these classes compare to the cohort? So be able to see which classes performed the highest in the school, which areas classes outperformed the school at the cohort average, and which areas where isolated teaching practice led to better performance, and how this could be shared in classes. So the case study here is that in a school, they were looking across at all of the questions, and they were able to see that this class outperformed all of the other classes. So they went back and tried to look at what did this teacher do. And this teacher had said that it was on a Friday afternoon that the students had mentioned that, oh, they learned this about cylinders, volume of the cylinder in science. So then what the teacher was able to do is he actually went on to ChatGPT and made an application task, and the students did it. And so when he went back and talked to his class about the MESHA assessment and how everything went, they remembered that there was a question that was like this task. So in a faculty meeting, they were able to look at all of the data, and then they were able to see, oh, what did you do? And he was able to share it to his colleagues. So it wasn't like they weren't sharing things. They have a OneNote where they do share their lesson plans, but it was something that he had done that he didn't think really needed to be shared, but it was something that the students really remembered. So they've added that to their lesson plan, and they've added it to the lesson plan this year. The next example of the report is a misconception report. So this is at the more granular level. So at the class level, you'll be able to see per your class what your common, frequent, and pervasive misconceptions are. So as we mentioned before, the assessment is multiple choice, but every multiple choice option is tied to a specific misconception to the skill of that question. So there's no distractor that's there. There's no choice of I don't know. So the data that you'll get back is you'll be able to see what option your students chose and what misconceptions that they might have. So a pervasive misconception is one where over 50% of your class has the same misconception. And this is probably something that you want to be reteaching or revisiting. If you have a common or frequent misconception, it's about 20% of your class having this misconception. This might be something where you just want to set some spaced retrieval and have them practice these questions again. So here is an example where there was a class where actually they scored pretty well, and they had 85% that got all of the answers correct, but 15% of the students, they all chose one option. So they didn't choose option A or they didn't choose option C. They chose option B. And this gave the teachers the misconception that they could focus on with that group of students. So we're going to get into now the results of the pilot that we just had in New South Wales, and then we're going to talk in more depth about some of these case studies. So in April, just this past month, we sat 1,278 students, and we had over 41,000 question responses. And the average mark was about 69%. So MESHA is not for everyone to get 100%. It is designed to be a diagnostic tool where teachers can now see where their students are at on the math journey. So it is a rigorous test. The easiest question, there is a range of questions. So the easiest question here is one that's from a stage 3 outcome, really, where it's a very simple 4 operations question. And then the hardest question is actually also a stage 4 outcome about lines of symmetry that usually is taught more in year 7, but because it's a more difficult shape with congruent triangles, this was something that was in year 8 and proved to be the hardest question, not only in New South Wales, but also in Victoria in both of the pilots. So why does comparative data matter? So comparative data matters. If you look here, this is where all of the questions are across the bottom, and then the percentage correct is on the y-axis. So the blue rectangles are in the middle, is that interquartile range, but you see there's also a top and there's also a tail. So if you think about where your school is sitting and you see how you're performing across all of the questions, you'll be able to see that this is where you're sitting compared to the cohort. So if you got 56% correct, is 56%, if we look here, at the hardest question, the one I just showed you there, the hardest question, just as question 7 here, if you see that there's a wide range of actually the top and the bottom. And if you know where your school is sitting, you can actually see how your school is compared to the rest of the cohort. To get a better image of what that actually means, this is actually some of the raw data. So let's say that you had 2 classes. So in School A, Class A, they scored 56%. School 2, Class B, they also scored 56%. So if you'll see here that in the first class, that their rank out of 64 classes, they were 21st out of 64. And that 56%, how is that? How am I going? If I only had my school data to look at, in this top one with Class A, you'll see that they actually performed 3% below the school. So then as a school, I might be quite concerned with how we're going. But if you look at compared to the entire MESHA cohort of other schools, they're actually 9% above the cohort. So still doing pretty well. You would still probably want to look into what's going on in the class, but this gives some of the balance to what that 56% actually means. If you look at Class B in School 2, they also scored about 56%. And they were ranked about 28th out of the 64 schools, 64 classes. But their gap to their school, they were 19% above their school rate. So they'd be thinking, wow, their 56% is doing really, really well. But then compared to the rest of the cohort, they were about 0.3% below the cohort. So this is something that they would want to look at as well, like how their performance was. So this is why comparison really makes scores more meaningful. Here's another example where there's 2 classes at the same school, but with different insights. So in this question, where it's about subtracting the fractions with the different denominators. If you see here in class A, so there was 87% got this question correct. And if you look at the discrepancy, about 8% chose option A and 4% chose option C, they might have just guessed at what those answers were. If you look at class B, where they have 31% correct, their data is very different in that there is 40% that are all chose option C. So 40% of this class all have the same misconception of that they use the incorrect common denominator. All of these questions, when we designed them together with Dr. Ashman, were intentionally created. The answer options and the misconceptions were intentionally created. So in this question, where it's 2/3 minus 1/6, the correct answer is actually 1/2. And a lot of students in year 8 would think, oh, 1/2 is not an option because 2 is not in the denominator anywhere in the question. So also, if you look at option C, which is what these kids answered, they could have just subtracted across 2 minus 1, 3 minus 6, but then ignored the negative. It should be actually negative 1/3. So this 40% would act as a signal to the teacher to investigate more on where the misconception is with subtracting fractions with different denominators. And then here's another example. This is one from one of the more difficult questions that we had on the test, where it's asking to simplify the following expression. So 60% got this question correct, and 36% all chose option B, where they didn't simplify. They actually evaluated the question correctly, so the math skill is correct. They understand that. But where they fell down or where they would lose marks is they didn't simplify, which is actually the command term in the question stem. And if you think about it, this is where kids would be losing their marks. So this is a really good data point to let teachers know what they should be looking at. So is it the math skill? Is it in simplification? Is it in index laws? Or is it just having a discussion around command terms? And often when we're teaching, stage 4 math, we're not really at that point yet. We're talking about HSC exams and command terms, but this is a great example of why reading the question and understanding the command terms is important. So in this case study, which actually is part of that data that I was showing you before about the misconceptions, this question was on the topic of using Pythagoras' theorem to calculate the shorter side. So as we said before, questions were intentionally created. In this image, the shorter side and the hypotenuse were created to not really be able to visually decipher which was the shorter side, which was the hypotenuse, but really understanding that the two sides that make the right angle are the shorter sides and the hypotenuse is the one that connects them. So the insight that the school got was that the accelerated classes scored below the cohort and the mainstream class. So the accelerated class on the right-hand side scored 41%, and that was 7% below the cohort. And even though it was 4% above the school, they still scored below the cohort. The mainstream class actually scored above the cohort and well above at the school level. So what they were able to do and dig deeper looking at the syllabus is that the mainstream class had just learned the topic, where the accelerated class had learned the topic earlier in term 1. This is from the Victoria pilot that was in term 3 last year. So when they saw the data, then they were able to see that actually that they needed to do some of the spaced retrieval, and they needed to come back and they needed to review the topic in their accelerated class. So the impact was that they then decided that they were going to incorporate spaced retrieval into their 2026 school year and make it part of their whole school numeracy plan. In the next case study, in this question, this is one about finding capacity and volume. And this question was intentionally written with the answer choices in square centimeters. So if the student was just looking at this question and knew it was volume and capacity, they should already know that centimeter square would not be an option. But in the question stem, it also states what is the maximum capacity of water it could contain in milliliters. So students would know that their answer should be in milliliters. The insight, again, was that the extension class scored well below the cohort and below the mainstream class. So the faculty meeting was, when they held it, they were able to use this data to talk about and to guide what was actually happening. And in a discussion, they found that their extension class had a heavy reliance on using formula sheets. So they knew that they were using the formula sheet, and when they talked to the students said, we didn't have a formula sheet, so we couldn't remember exactly what we were supposed to do. Whereas in the mainstream class, not only had they just recently learned this topic, but because of the number of practice questions that they had done, and they did not have this on a formula sheet, the students were more comfortable in understanding how to solve the question. So the impact was, even though that this question, the way it was written, did not require a formula sheet. So on the MESHA assessment, there's no formula sheets. This suggested to the teachers that the students had an over-reliance on using the formula sheets. So they've decided this year to remove formula sheets, especially on this topic, and they're going to reassess to see if there was any difference between using the formula sheets and not using the formula sheets. Okay, so we're getting to the part now about joining MESHA. So in Term 3, we are offering sponsored spots for New South Wales schools. So your first MESHA assessment is fully sponsored at no cost. It is available for years 7 to 9, and it is aligned to the New South Wales curriculum. It includes the assessment delivery, the reports that I had just mentioned, the comparative insights, everything that will be delivered in 10 days. So please remember, this assessment only takes 40 minutes. It's designed to fit within your normal period. We will provide full onboarding. We have a New South Wales team that will come out and meet with your schools. We can get on calls. We have just tested this in the New South Wales pilot. We also have just released this in Victoria with over 11,000 students sitting the assessment. So we're here to help you with support and simple access. So there's no new logins. You can use single sign-on for all New South Wales department schools. So very easy assessment access. For more information, we do have a YouTube channel. The link is below. You can link and go see there, where there's more in-depth videos from Dr. Ashman that explain more about MESHA and the reasoning behind it. Can answer some questions about the value for school leaders. MESHA is not adaptive, and the reasoning why that was done on purpose, what schools can do with MESHA insights that they cannot do with NAPLAN data, why targeting misconceptions are so powerful, and many more. So you can scan the QR code here, and you can email us to get in touch and find more information out about MESHA. We would love for you to join. Again, just try it out. There's no cost to your school. You could try for yourself and see how you could use these insights to help you identify the gaps that will lead to growth in your mathematics classrooms. Thank you.